the Smart Buildings Academy podcast with Phil Zito, episode 354. Hey folks, Phil Zito here, and welcome to episode 354 of the Smart Buildings Academy podcast. In this episode, we are going to be diving into Bacnet. We're going to be looking at a lot of different Bacnet, basically concepts, for lack of a better word. All right, as always, everything can be found at podcast.smartbuildingsacademy.com/354. Once again, that's podcast.smartbuildingsacademy.com/354. I highly recommend that you go and check out that link in probably about an hour and a half, as I'm going to include a lot of previous episodes that we had on the topic of Bacnet. All right, so what is Bacnet? Bacnet is a protocol that has existed for a long time. It's known as the 135 standard, and it's a standard developed by ASHRAE. It is de facto the most popular protocol in the market right now. And there's kind of three flavors of it, and we're going to go back to these. And the three flavors are Bacnet Mstp, which is master slave token passing. It's a RS-485 standard. We'll talk more about that in just a little bit. There's Bacnet IP, and there is this new Bacnet SC, or Secure Connect. Now, I know there's Bacnet over ArcNet, there's Bacnet over Ethernet, there's even Bacnet over LAN, but we're going to focus in on Bacnet MSTP and IP because they are the most commonly installed versions of the protocol. As always, if you have any questions during this podcast, do not hesitate to, interject, whether you're on LinkedIn, YouTube, Facebook. Just, say, hey, I got a question about whatever, and just ask it. And if I see it, I'll answer it. All right. So the first thing we have to understand, and I think where a lot of people get tripped up, is you need to understand Bacnet is an object-oriented protocol. Now, what does that mean? Because a lot of people don't understand the term object-oriented protocol, and it throws folks for a loop very often. Well, if I were to say to you that I drive a van, right? I drive a van. A van is a type of vehicle, right? So Bacnet has dozens upon dozens of objects. One of the most common ones we work with is the device object. So anytime you go and you install a Bacnet controller, you install a Bacnet supervisory device, you install a Bacnet workstation, etc., you are basically instantiating, you're implementing a Bacnet device object. All right. And then a object can have properties, and it can have sub-objects, and it can have services. So we're going to focus in first on the device object and its properties. Then we're going to talk about sub-objects, and that's where we'll get into the who is, I am, who has, I have, discovery services. And then we're going to go through properties. And yeah, we should have a pretty good understanding of that. I'm going to take a sip of water because, as always, I do these and my throat just gets super dry. All right, so you have this device object. Let's just say it's VAV101. That's your device. It's a VMA, a VAV modular actuator. So it's a VAV controller with a modular actuator inside of it. And maybe it's Bacnet Testing Laboratory, BTL listing is an ASC, application specific controller. Now, maybe it's an AAC, an advanced application controller. And I'll explain what BTL means as well. So how we do things here is I throw a bunch of terms at you, and it may seem disjointed, but I want to expose you to the terms on the first go around. And then as we get into the examples, I'll further define the terms, and then I'll give you even better examples. And by exposing you to the terms multiple times, you'll start to kind of really pick up what's going on. All right. So we got this device object, this VMA, VAV modular actuator. And what's going on here is this actuator device, right? It's going to have objects and it's going to have properties. Some of the most common properties that we have are going to be things like device name, or things like device ID, or things like device description. Okay. And there's required and there's optional properties. I don't have these memorized, but you can look up the 135 standard and you can find the required versus the optional properties. And when you have a BTL listing, you have properties and services and bibs and all sorts of stuff that are required. Once again, I realize for a lot of you, these terms may not make sense. I will do my best by the end of this podcast, and I will judge the success of this podcast by your understanding at least a rudimentary level of these terms and concepts towards the end of the podcast. I'm going to take a sip of water. Okay. So as I mentioned, we have this VAV object, and I equated it to my van, right? So I drive a minivan, and my minivan has properties. For example, one of the properties is how many doors does it have? Well, it has 5 doors, right? It has a tailgate, 2 side doors, 2 front doors. And it has a property of color. What color is it? It's gray. Well, this VAV box controller, this AAC or ASC BTL profile, which once again, Bacnet Testing Laboratory profiles, those are profiles of devices. And in order for a device to qualify to meet that profile, that it has to support certain services, certain objects, certain capabilities. This becomes very important later in this episode when we talk about integration and interoperability. All right, so once again, we have this VAV controller, and it has some properties: device name, device ID, device description, manufacturer type, version, Bacnet version, etc. Some of these properties are required. Some of these properties are not required. Some of these properties must be unique, like device ID. Some of them do not need to be unique, like device description. All right. So once we understand properties, that's how we go about setting up some of the parameters. And it's quite often one of the areas folks mess up. For example, they'll have duplicate device IDs. They'll have duplicate MAC addresses. They'll have improperly matching Mstp speed rates, etc. And when these properties are set wrong, that causes issues with interoperability and connectivity. But we'll talk more about that later. So by now, you should understand the concept of an object, and you should understand the concept of properties. Next up, we come to the concept of objects of objects. And this is what throws a lot of people for a loop, is within an object-oriented protocol. Like if you know anything about programming and you understand classes, you can have a superclass and you can have a subclass and you can have a class. Well, if you think of a device object as a superclass, so it sits at the top, and underneath it you have subclasses or types of, right? This is a very poor analogy for those of you who have a programming background, because it's not exactly how it works, but I'm trying to make an example here. So you have the superclass, this kind of high level class object, right? And then that is device. And underneath it, you may have analog value, analog input, trend object, schedule object, multi-state object. Give me 1 second. Let me take a sip. I'm getting better at learning to mute when I have to clear my throat here. All right. So like I was saying, you have objects, and these objects are dependent on this device object. They're basically a one-to-one link, right? So you have this device object, and then it has its analog inputs, has its analog values, analog outputs, etc. And we'll talk about priority arrays and things like that. But what happens, and this is our first concept here, what happens when we initiate a device, whether it's on an MSTP trunk or it's on an IP bus, what happens is we instantiate 2 services. We initiate 2 services. The first service we initiate is called the Who Is I Am service. And what's unique about the Who Is I Am service and the Who Has I Have service are they are broadcast discovery services. So these are messages that are coded inside the controller. And you may go and actually execute from a supervisory device, which I'm assuming you understand basic building automation architecture if you're listening to a Bacnet 101 podcast. So I'm not going to go into architecture of like what's a supervisory device, what is a server, what's a controller, what's a field trunk. I'm assuming you know that. So if I seem very light on that, it's because I'm making the assumption that you understand those concepts, because this is purely focused on Bacnet. But you have a supervisory device that has a field bus or an IP link, and you're executing a device discovery because you want to build your tree inside your supervisory device, your tree of Bacnet objects, right? Device objects. And so what you do is you execute a discovery, and what happens is that discovery then goes and it sends, right? It's going to send a who is message. And I'm not going to get into BBMDs and BDTs and subnets and foreign devices just yet, but it's going to send, the supervisory device sends a who is message. Now, a Bacnet device on a trunk or on an IP link is known as a Bacnet node. So it's known as a back node. So what happens is when this discovery gets sent out, it says who is, that's a broadcast message. So I'm going to skip over IP basics here and those kind of concepts. It's a broadcast. So in the case of IP, it gets sent as a broadcast. In the case of Mstp, it gets sent as a special token that gets sent to all the devices. But what happens, right, is you've got this broadcast message that goes out, and then each device will send a unicast message in the case of IP, or it'll respond to the token in the case of Mstp. It'll send a singular message back. And within the supervisory device, a data array is built of these back nodes. Now, this is really important because a lot of folks, they misunderstand services, especially who is, I am, who has, I have. And by missing this, they mistroubleshoot, they misdesign, misimplement. But what happens is this back node will reply from the broadcast to the array on the supervisory device, the software array, and that will start to build an array list of all the back nodes. Now that becomes important for a couple reasons. It's one of the reasons why you can discover devices with duplicate MAC addresses or duplicate device IDs. And sometimes one can be online and sometimes the other can be online, because whichever device on that array receives heartbeat code first will be online, and then the other will be offline. All right. But what happens with this array list is now you have an array of back nodes, and you need to build out the object list that exists under these back nodes. And this is where the who has, I have messaging comes into place. And this interrogates the device object, and it pulls a list of any flagged Bacnet discoverable object. So this is where your AIs, AVs, AOs, etc. will be discovered and will be pulled under the device object. So you have objects nested under objects. So you have your device object. Oh, excuse me, didn't catch that one. And you have your supporting objects. Okay. Now at this point, we can go and we can start to discover our objects, add them to graphics. We can start to set up the properties of the individual objects. Okay, so you with me so far? We have supervisory devices that discover objects, device objects on either an IP bus or an Mstp bus. And those objects, those device objects build an array list, which can then be interrogated to discover the point objects, whether those are physical points or logical points, as well as other things like trend objects, schedule objects, etc. Those can all be brought in. Okay. And then, as if to make things more complex, is that objects can also have extensions, right? So you have your objects, your AV objects, your analog inputs, analog values, etc. And you can have a trend object attached to that object. So you can have a trend object attached to an AI or to an AV, and you can have that recording data. And we'll talk about trends. We'll talk about COV versus interval trends in a little bit, right? So we're kind of building out this thing. Okay, so once again, up to this point, we have device object, we have sub objects, AI, AV, etc., and we have extensions, right? So we have trends, etc., etc. Now, all of these devices, these Bacnet devices, need to communicate with one another. How do they do that? This is where the IP or Mstp portion of the Bacnet protocol comes into play. So Bacnet is an interesting protocol in that it covers the application layer, it covers the logical layer, and it covers the physical layer. So up to this point, we've only talked about the application layer. We've talked a little bit about the logical layer with things like or who is, I have, who has, or who is, I am, who has, I have services. But now we're going to get more into our physical layers. So IP, pretty straightforward internet protocol. Each device, so Bacnet address on an IP device is a combination of your IP address and your device ID that creates your Bacnet IP address. That's why you need to have a unique device ID. Okay, and then what happens is Bacnet is a non-routable IP layer 3 protocol, not layer 4, layer 3 protocol. It utilizes UDP, which is a unreliable communication mechanism. And it uses this concept called a virtual link, Bacnet virtual link layer to create connections. If you're like, what the F did you just say, Phil? Don't worry. I promise this will make sense. Okay. So picture this. You've got a building. And your building, I'm assuming you understand what subnets are. I'm going to take a sip of water real quick. So you got a building. And this building has subnet 1 in it. Subnet 1 has 4 Bacnet devices. So one building, subnet 1, 4 Bacnet devices. Then you have another building. Subnet 2 has 4 Bacnet devices. You want the devices on subnet 1 to communicate to subnet 2. First thing that has to happen is you have to be able to take the supervisory device and you have to be able to discover the devices on subnet 1 and subnet 2. And you can do this a multitude of ways. You can use routers, you can use supervisory devices, etc. But the important point is each subnet needs a Bacnet broadcast management device because, as you know, if you understand IT, broadcasts, right? So broadcasts can only travel in the subnet they're in. Otherwise, if they could travel across subnet boundaries, you would have issues where basically the internet would shut down anytime a broadcast was sent because it would just self-propagate all over the place. But what happens is these Bacnet broadcast management devices that are typically in a router or in a supervisory device, they host what's called a BDT, which I'm probably going to butcher the acronym because I don't have everything memorized. But if I remember correctly, it's either a broadcast distribution table or a Bacnet. I'm pretty sure it's broadcast distribution table. Well, this is a list of all your BBMDs. And so basically anytime a broadcast is sent from that BBMD or received to that BBMD, it can then forward those broadcasts to other Bacnet subnets. Now, the response is not an issue. It's the initiation that's the issue, because the initiation of the who is I am is a broadcast message. The response is a unicast message. So unicast can travel across subnets as long as there's a routing table. It's the broadcast that cannot travel across subnets. That needs to be forwarded by a BBMD. So IP, how it works is you have a IP address and a device ID, and you have your BBMDs and your BDTs, and then things are distributed between the networks. Now, there's a little bit more to this with UDP ports and how you can actually segment Bacnet via UDP ports. I got to take a sip of water real quick. 1 second. But basically, what happens with BBMDs and these Bacnet networks is you communicate between the Bacnet networks with the BBMDs for discovery purposes. But then after that, we use unicast and multicast messages, which we're going to talk about right now. So in this IP world, you've got these devices, they're discovered, but then device 1 on subnet 1 wants to talk to device 1 on subnet 2. How is it going to do this? Well, if they're already discovered, then it is a simple unicast message. And this is where this client and server methodology comes into place, because you have Bacnet clients and you have Bacnet servers. So clients can initiate requests and servers respond to requests. So you'll see that in a BTL listing as like A or B. And so what happens is you have, for example, I'm sitting at my user interface. I want to discover a Bacnet point. So I discover it using the who has I have. I populate that point and I add it to the graphic. Now I want to go and read that point data. I want to know, what is that point value? I'm going to initiate what is called a read property service. Now, a read property service, or a read property multiple service, that is a unicast or multicast message. What that means is I do a read property from device 1 that goes to the supervisory device, looks at the array, and it looks at my links, and then it knows which IP address to direct that to. In the case of IP, Mstp is a little different. Read property multiple, let's say I set up some logic and I want to read all of the outside or all of the discharge air temps from all of my air handlers into my central plant controller. Well, that would be a read property multiple. And so I would initiate a read property multiple and it would send a multicast to a bunch of devices. I'm going to take another sip of water real quick. So what happens is you have these multicast and unicast. Majority of Bacnet messages are unicast and multicast. So if you've discovered your devices and you're sitting there trying to, and they're not writing to one another, but they're discovered, most likely you don't have a BBMD BDT issue. You most likely have some sort of routing firewall issue blocking messages or something of that nature because of how unicast versus multicast versus broadcast work. All right, so up to this point, we've talked about the device. We've talked about objects and nested objects. We've talked about extensions. We've talked about discovery. We've talked about IP. We're going to shift over to Mstp. Like I said with IP, just before I leave that, if you get the BBMD right, you get the BDT right, you get the IP addresses right, and you have unique device IDs, that's going to be 90% of the issues you're going to run into. Mstp is a whole nother ball of wax. I see so many folks who are like, I don't understand with Mstp why it's so difficult. And my first question to folks, and they don't like this question because a lot of folks don't know how to answer this question, is, did you follow the RS-485 standard? Bacnet Mstp, Modbus RTU, they're both based on the RS-485 standard. That is the standard that says 32 devices across 3 segments, maximum 64 devices, maximum 3,300 feet per segment, 2 supported baud rates of 9,600 or 38.4. Those are the standards. Now, I realized for those of you listening, that goes against a lot of the OEM standards. And, I've done it. I've had a supervisory device with 200 controllers on an MSTP trunk. Or sorry, 100 controllers on 2 MSTP trunks. So 100, 100, 200. And you could do that, right? You'll see a lot of manufacturers will say 3 segments, 5,000 feet, 100 devices max, and, any baud rate as long as the baud rates all match. The thing is, the RS-485 standard and ultimately the Bacnet standard, if you follow RS-485, I've yet to see really a trunk that had issues following the RS-485 standard. Now, we'll talk about end of lines. We'll talk about reverse polarity. We'll talk about baud rates. We'll talk about MAC addresses and MAC address sequential addressing for long trunks. But essentially what happens in a MSTP, without getting too crazy on you, is it's master-slave token passing. So you have master devices and you have slave devices. The master devices are MAC addresses 0 to 127. I think I'm remembering that correctly. Typically, the first address is the supervisory device address, not always. And then on those master addresses are ones that can, initiate a token request as well as send a package back with a token request. So slave devices are not going to be able to initiate like read properties, etc. They are typically server objects. They're going to respond, but they're not going to go and initiate. So you're not going to go to like an ABB VSD or VFD, which is a slave device. You're not going to go to that and do a discovery from that. You're not going to go and do a object initiation from that, okay? I just want to make sure real quick, everything. Okay, cool. Thought I was having an issue with audio there for a second, but I am not. Okay, cool. All right. So like I was saying, with the slave devices, you're not going to go and be able to initiate a lot of the client services. So just realize that. Now in MSTP, typically what we will do is we'll use a media access control. So MAC address, and it is a physical address of the back node. So it is typically a dip switch, sometimes set inside the software, typically set outside on the hardware with a dip switch. Using basic binary with a 8-bit array. So, bit 1 is 1, bit 2 is 2, bit 3 is 4, and you just flip them on to add up to whatever Bacnet MAC address you need. Now, as always, you need a device ID, a unique device ID, and a unique MAC address. Those 2 addresses come together to form your Bacnet device address on an MSTP trunk. Now, what will happen is the token will go from device to device to device in sequential order. So you'll go device 1, MAC address 1, MAC address 2, MAC address 3. And this is why on long trunks, you typically are told address sequentially, because it will make your trip faster, especially with low baud rates. Now, baud rate is the measurement of speed for Bacnet MSTP. Okay, so up to this point, we have a RS-485 standard. It's a 2-wire to 3-wire serial network. Series means you have a receive and a transmit and a receive. So electrical pulses go out the transmit, they come back the receive. Hence why it's polarity sensitive, because if you swap the receive and transmit, you're going to have electrical collisions and nothing's going to work. But what happens is with this 2-wire or 3-wire, if you've got a neutral basis wire, what will happen is you will send electrical signals across. Those were communicating typically 9600 or 38.4 thousand baud. Those are the 2 default Bacnet baud rates that any BTL device is required to support. And faster the baud rate, obviously, the faster data is going to flow. I'm not going to get into what baud rates are, but just think on-off signals, basically. So what happens is the baud rate and the length of wire determines how long things take to communicate. Shorter trunks, faster baud rates, faster communication. So you've got this, let's just say 9600 baud across 15,000 feet. That's going to be a very slow trunk. If you organize your devices, let's say you have 100 devices and you organize them sequentially, your tokens are going to travel significantly faster. If you've got, I think it's 114K, it may be 118K, I don't remember off the top of my head. But if you got 118K baud rate, that's screaming fast. Things are going to communicate much faster regardless of your communication transmission length. Okay, so we talked about transmission length, we talked about baud rate, we've talked about MAC addresses. Now let's talk about segments and end of line. So Bacnet segment, according to the RS-485 standard, is 3,300 feet or 32 devices, whichever comes first. So what happens is the segment would be from your supervisory device to the end of the segment. Now, let's say you want more than 32 devices. You want 64 because you want to maximize the RS-485 standard. Well, you need to add, right, a repeater. And that repeater is going to go in between segments and it's going to clean the signal and boost the signal. And that's going to allow it to continue. But eventually at the end of the signal, you're going to want to end the wires. Now, the problem is you've got this electrical signal traveling across the wire and it's going to keep traveling and then it's going to reflect back on the wire. So how do we deal with that? We deal with that with oh my gosh, forgot off the top of my head, 120 ohm resistor. I'm pretty sure it's 120 ohm resistor. Like I said, I never memorize anything I can Google, but you put a end of line resistor in place. It's either a dip switch flip or it's a wired in resistor. And that resistor is going to dampen the electrical signal and it's basically going to keep it from reflecting back onto the comm trunk and introducing a bunch of noise. So right now we understand Mstp. So if you don't cross polarity, you follow the RS-485 standard, use your end-of-line resistors, you address sequentially, you're going to be pretty solid. I've yet to see an Mstp bus get messed up short of like being next to an MRI machine and getting a bunch of interference. Other than that, you should be pretty solid. Okay, so we've talked about Bacnet devices. We've talked about IP. We've talked about objects. We're going to take a second to talk about trends. We're going to talk about change of value. We're going to also talk about interval. So this is something that throws people for a lot of loops, right? People are like, change of value, interval, I don't understand. Well, it's really, really, really simple. So interval is basically just a sample. So you would do a read property sample basically, and then put it into a trend array buffer. And that is going to occur every 600 seconds, 300 seconds, whatever. Then you have change of value. Now, change of value is another really simple one. And basically what you do is on the actual device itself, you set up a change of value listener. This is typically a trend object extension. And you will say when it moves by a certain amount, so let's say we have degrees Fahrenheit, and we want a change of value of 0.5 degrees. So when our current, so it has an array that's holding the current property. And when the new property, the new value rather, for that temperature property object, once that changes, right, that value changes, maybe it goes from 71 to 71.5, that triggers the change of value, which then gets sent to from the change of value client to the change of value server, and then gets stored in the trend array. It's actually fairly simple. A lot of folks like change of value because it gives you more real-time data. They didn't use it as much in the past because folks were worried about data throughput, but with higher baud rates and better installation guidelines now, you can use COV pretty reliably. Okay, so we talked about Bacnet objects, we talked about devices, we talked about object types, we talked about services. I'll do a little on BTL, and then we'll call it a day, right? Because we're at about 30 plus minutes. So BTL, Bacnet Testing Laboratories. Essentially, if you've never been through a BTL test, what happens is you pick the profile for your device. You say, this is an AAC, Advanced Application Controller. So it has to support the following BIBs, which are Bacnet interoperability building blocks. And a BIB is basically a list of services and object types and things like that that your Bacnet device supports. And then the Bacnet BTL folks will come and they'll be like, okay, demonstrate this, show me this. And you'll demonstrate the BTL listing capabilities exist, both from a client perspective, but also a server perspective. Remember, these aren't clients and servers in the IT sense. These are clients and servers from a functionality perspective, being that a service, right? A client will initiate a service, read property, write property, etc., and a server will respond. So a device object can have both client and server capabilities in its BIBs. Well, once you've proven that out, your BIB or your BTL protocol implementation conformance sheet, your PIC statement gets put on the BTL site, and then you can tell what objects support. So when I see a lot of interoperability issues, it tends to stem from three things. So if you're ever tired of your techs calling you being like, how do I integrate with this chiller again? How do I integrate with this again? What that tends to stem from is one, not understanding how to read BTL lists, not understanding how to read PIC statements, and then not understanding how to read object arrays. So I'm going to list from, well, this isn't going to be in any order. I'll just spitball them however they pop in my head. One of the first things I see is people trying to discover analog inputs as analog values or analog outputs. So, and that could be for binary or multi-state. But basically what happens is in the Bacnet world, an input is a read-only object. It does not have what is called a priority array. So Bacnet has what's called a 16-bit priority array, meaning there's 16 bits that can be written to. So if you've ever done an operator override on a building automation device via Bacnet, you've initiated typically priority array 8, which is the operator override. And, you know, you have like priority array 1, which is life safety. You have 16, which is like global. And so the lower the priority array number, the higher the priority. So if you write to well, you can't write to 1, but if you write to 8, that takes higher priority over 14 or 15 or 16. So what happens, right, is you have priority array on analog values and analog outputs, not on inputs, and the same for binary and the same for multi-state. So I see a lot of people discover a chiller and they're like, I can't freaking write to this point. I've been commanding it all day. And you go into the points list and you're like, well, no shit, you can't write to it. It's an AI. It's got no priority array. It's got nothing to write to. So that is one of the issues, right? Is that right there? Another issue I see is people not understanding baud rates. And so they'll put in a VFD, they'll put in a Unicast Bacnet flow meter, whatever, and they'll just whatever baud rate. And then there's data collisions out the wazoo. So that's another thing I see from folks from an integration perspective. But the biggest really is those inputs and outputs and not being able to read a points list. That's huge. People like struggle with that so much. The other thing is not understanding that things need to have unique device IDs, right? So make sure you have a unique device ID. Make sure that you have a network. Well, I'm not going to get into network numbers, but make sure you have a unique device ID. Make sure you have a unique MAC address. But that brings up another point. You only have to have a unique MAC address for the Mstp trunk you're on, because remember, and this is the same for subnets, remember a Bacnet device's address is device ID plus MAC address, right? That's why you can have a device 32 on trunk A and a device MAC address 32 on trunk B, but they have different device IDs. And that's how they can work together, because the Bacnet address is device ID plus MAC address. And the same with IP. That's why you can have on two subnets, right? You can have 192.168.1.100 on one subnet, device ID 1000, and then the exact same IP address on a separate subnet. You can have mix that up. That's why you can have device ID and then IP address. I lost that thought. Totally slipped my brain. It's been like 40 minutes now. Drink some more water. Okay, so I talked about that. I talked about addressing. I talked about BTL lists. I think that's the big ones. So 40 minutes. I hope you all got like a lot better understanding of Bacnet. I hope it's like feels a little less complex. I know I threw a ton of terms at you. My hope is that coming out of this, you feel more experienced with these. With that, I'll see if we have any questions real quick, and then I'll give you all some time back in your day. I hope you all find this valuable. If you want like much deeper learning on Bacnet, definitely check out our Bacnet course. I'll link to it at podcast.smartbuildingsacademy.com/354. Once again, that's podcast.smartbuildingsacademy.com/354. That'll be up in probably about 30, 40 minutes. That being said, let me go through the list. See, so thanks, Phil. You're welcome. Great podcast. Thank you. If y'all are finding these podcasts helpful, like we do these 3 times a week, most of the weeks, and they're completely free. Go to iTunes, leave a review, go to YouTube, like and subscribe. You know, those things really help spread this. And like I said, probably 90% of our content's free. So yeah, that would be very much appreciated. Yep, definitely. So I will respond to you. See, you're asking for the Bacnet course link. I will respond to you about that. I'll just send you a private message, and I'll also post it in this thread. Let's see, anybody else? Any questions I can answer for you? I mean, I built Bacnet stacks, so I've written code for Bacnet stacks. I helped companies build their Bacnet stacks. I've done a ton of integration, like a ton. So, yeah, if I can help in any way, I'd love to help. I'll chill here for about 30 seconds. If I don't see anything come in, I'll give you all some time back in your day. I really got to get humidifier in here. Holy moly, man. I don't know why it gets so dry in this office. It's like 60% relative humidity, but yet in here it gets so freaking dry. It's ridiculous. Okay. Not seeing anything. That's about it. Thank you so much, everybody, for being here. I appreciate it as always. I hope you enjoyed this. I'll see y'all on Wednesday. Every Monday, Wednesday, Friday, 12 p.m. Pacific time until daylight savings time, and then it'll be 11 a.m. Thanks so much and take care.